In this video, we'll talk about continuity as it applies to functions. And it's one of those things that in mathematics, it's fairly simple to explain what it is, but it's very difficult to define what it is. So let's go ahead, jump right in. Let's talk about continuous functions. So if a function is continuous, it just means that it's smooth, there's no breaks in it, and a good way to think about it is that if I have a function and I'm looking at its graph, I can draw it and I don't ever have to pick up my pen. I can just draw it in one smooth motion, as opposed to, let's look at one that's not continuous. A classic example is 1 over x. Notice I have to draw it in two pieces, and those two pieces are continuous. However, the entire function, there's one break. Now this is where you get into the kind of nitty-gritty bit of it, is that, yeah, it's continuous for all values except 0. So when you look at a lot of textbooks, they look at continuity not as an entire function, they look at it as in a point. Is a function continuous? And that's where things get a little difficult to define. But for our purposes, if a function value exists at that point, it usually means it's continuous, barring a couple of exceptions, which we'll talk into. So really the easier part to define are the discontinuities. So discontinuities, there are 3 types. And we'll go through each one. But they're just different ways that a function can break. So let's take a look at probably the most common, the most classic would be infinite discontinuities. So in this case, let's say we've got 1 over x, we have our graph, and at 0 we have asymptotes. Both of these ends go off to an infinity, one positive, the other negative. So infinite discontinuity. Now likewise, if I have 1 over x squared, it also has an infinite discontinuity, even though both ends go to a positive infinity. So this is kind of 2 examples of the same thing, I guess, but they're just slightly different. And we can have functions with more than one infinite discontinuity. So a lesser common, I guess, discontinuity is a jump discontinuity. And these result strictly from piecewise functions. So we're not going to spend a whole lot of time on them. However, it is useful to be aware of it. What they would look like is if we have, say, a line, and then it jumps, and then it becomes a quadratic kind of thing. This jump is a discontinuity. The function breaks. I can't draw it all in one smooth arc. It's just something that happens sometimes with piecewise functions. But it's not necessarily something to be concerned about, but it's something to be aware of. Now this one, the last one, is more common than jump discontinuities. It's a little bit strange. So a removable discontinuity basically is just a hole or a gap. And usually it's for one value. So like, for instance, it'll look like you're going along, you'll have a gap at, say, I don't know, x equals 4, and then it'll just keep going. Now, that's weird, but if we think about it, these result from domain issues. So as an example, let's look at the function y equals x squared minus 16 divided by x plus 4. Now, knee-jerk reaction, this looks like it's going to be a rational function. It's going to look like either the 1 over x or 1 over x squared, one way or another. However, if we simplify this top expression, it's a difference of 2 squares. We can factor it, forgive me, not simplify. So we'll have x plus 4 times x minus 4 over x plus 4. Now you may notice the x plus 4's cancel out. Now, if I go back to the original domain of the function, I cannot plug in a 4. Otherwise, I'd be dividing by 0. So domain-wise, x cannot be 4. However, if I graph just this piece, this x minus 4, it's going to look a lot like this line I graphed over here. I just have to respect the original domain because x cannot be negative 4, which I guess should be over here. But the concept still applies. Removable discontinuities, they're kind of like infinite discontinuities, and the only way that you would even have one is if you have some sort of cancellation. So it won't always happen that way. Like if I had another x plus 4 term down there, we'd still have our infinite discontinuity. But it's just something to be aware of. If you don't have any cancellation, you're probably just going to have infinite discontinuities. It's just something to be very cautious of and very aware of.